Hello everyone, my name is Domina Delač. I am assistant at University of Zagreb Faculty of Agriculture. My main area of research are the effects of fire and biomass burning on soil and water properties. Also, I'll deal with mitigation of fire effects on soil and restoration of burned areas in Mediterranean environment. I will present my research entitled Short-Term Effects of Pile Burn on Nitrogen Dynamic and Nitrogen Loss in Mediterranean Croatia. This research was supported by Croatian Science Foundation under the project Influence of Summer Fire on Soil and Water Quality. The exact impact of burning on soil hydrology and drivers of post-burn lead degradation are quite extensive and usually not fully understood. The aim of present research is to assess the impact of different burn severities on soil degradation, hydrological response, and with ammonium and nitrate concentration and data loss, estimate the soil fertility. So, how burning affects the soil? Combustion of biomass is a quite complex process. In order to understand the burn effects on soil and hydrology, it is crucial to understand burning itself. Burning I describe in terms of behavior, amount and the rate of heat released, the residence time and fuel consumption. In the context of burning, we can speak about direct and indirect impact. Direct impact is attributed to the heat pulse in the soil which determines the burn severity. The extent of the change is generally determined to a large degree by soil temperature reached during fire and the length of time that high temperature are sustained. Given that burn severity is a response to the amount of energy heat released by burning. Indirect impact is oriented on the soil and water response in post-burn period, which refers to the impact of burning on runoff and erosion. Indirect impact is considered to depend more on soil change and it's often determined by behavior of post-burn rainfall events. So, indirect impact is correlated and it's controlled by direct impact. Critical interest for studying the effects of burning on soil properties and is to what extent the heat generated during burning will alter post-burn soil and water response, such as soil fertility, soil erodibility, and the generation of runoff. The research about pile burning and their effect on soil are lacking. This research is mainly oriented on the pile burn effects on soil and hydrology. This method is very often used in Mediterranean basin and also in forest management. Combustible biomass loads have increased due to large-scale depopulation of rural areas and associated land abandonment. Pile burn of cutting debris is a silviculture technique that is widely used in the entire Mediterranean basin, mainly by agriculture workers to eliminate slash and crop stubble. Burning agriculture residues in piles provide cost-effective alternative for reducing residues when prescribing is forbidden or without local bioenergy facilities. Burning biomass heat the soil, direct impact, changing their properties depending on the severity of burn. In the period post-burning, the ash produced, indirect impact, will affect the soil properties and hydrological response. The positive aspect of this practice are that burning agricultural residues are cost-effective alternative when we can on some other way when we can't on some other way use the accumulated biomass or when the area don't have local bioenergy facilities. Pile burn affects relatively small and localized burned areas, and also one of the good side is that easily conduct on the most weather condition. The negative aspect of this method are that higher amount of burned biomass produce high heat pulse in the soil as the large amount of are consumed on relatively small area, which lead to detrimental effects on the soil and thus produce change in hydrogeomorphological process. Nitrogen loss by volatilization is well documented, but less attention has been paid to the impact of pile burning on soil nitrogen chemical forms and losses in overland flow. Nitrogen loss occur through the combustive organic matter or water and sediment transport, contributing to water pollution. The nitrogen volatilization starts at 200 Celsius degrees, and the losses increase with temperature increasing. The nitrogen that is not volatilized remain in the ash and can be converted to other available inorganic forms like ammonium and nitrate. The process behind decreased inorganic nitrogen losses after burn is still not well understood because the complex and the cycle of nature of inorganic nitrogen transformation. During burning, temperature controls the nitrogen release rate depending on burn severity. Almost all nitrogen is almost volatilized at temperature higher than 500 Celsius degrees, and there is an increase of inorganic nitrogen. High burn severity leads to a higher nitrogen loss through the erosion or runoff. After a moderate severity burn, 300 Celsius degrees, substantial part of soil organic nitrogen remains or change its form. So our location of study area is in the Republic of Croatia near Vrana settlement. It is located on North Dalmatian, Mediterranean part of Croatia. It has southwest aspect and is positioned on sloped area around 18 degrees. According to Köppen climate classification, the climate is Mediterranean with warm temperature and full humidity and warm summer. Experimental design included piles and unborder treatment control. Control treatment was covered with undisturbed natural vegetation like Mediterranean maquish, shrubland, and meadow plants. Moderate severity burn was filled with 100 kilograms per 10 square meters barley straw. High severity burn was filled with 100 kilograms per square 10 meters barley straw and also 150 kilograms per 10 square meter wine stream. Before biomass deposition, 50-meter rings were set up downstream for runoff and erosion collection. Pala was burned on 18 March 2019, 26 and 40 minutes duration and most severity, high severity plot. Around 10 square meters was the area of one treatment. Here represent the starting of pile burning. The biomass on every burn treatment was set up equally on every ring to have the same amount of biomass and to obtain the same burn effect on each ring. Pile burn are conducted in early spring when most farmers burn their unwanted residues in this study in this area. Here represent two burn treatments. The first that can be noted is the difference in ash color. On left side is unbordered treatment, and on the right side are the bird treatment. On where there is the black shaded material is moderate severity burn. On the right side of the right picture, it's grayish and it's produced by high severity burn. Around 300 degrees temperature was on moderate severity burn. On high severity burn was higher temperature, and according to that, the higher temperature produce more mineral composition and more mineral components in the ash. Burn severity was also assessed by observing ash color using Mussel color chart. As ash can be used as an indicator of burn severity since it is product of combustion of biomass. In simple terms, ash is the residues produced by burning. Methodology of the research. Ash samples were collected in fire repetition on both burn treatment immediately after burning. Soil samples from 0 to 3 centimeters depth were collected in the vicinity of each plot 5 days after burn every 3 months. In the ash, a soil sample percentage of total nitrogen was calculated. The first runoff was collected 5 days after burn and then approximately every 25 days in a period of 247 days after major rainfall events. In the laboratory, volume of runoff was measured and the concentration and loss of ammonium nitrate was calculated. Sediment yield was determined by filtering runoff samples, and from that sediment concentration was calculated. Total nitrogen loss was determined after calculation of total nitrogen concentration with the mass of sediment yield. Rainfall data was obtained from the nearest station of Croatian Meteorological and Hydrological Services, and from that data of maximum 30-minute rainfall intensity was taken. All the analysis was performed in the analytic laboratory at the Faculty of Agriculture, University of Zagreb. We can see there the runoff samples from one sampling date and can be noted the difference in runoff volume. Also, they represent the extraction of the sediment yield, and on the right side represent the runoff filtration through active carbon for later analysis on ion chromatography on DNX system. Here represent the control treatment to see variability in sampling date. Just 5 treatments, and we can see that vegetation cover was mostly full or during whole sampling period. Here represent the variability in sampling date on mode severity treatment. We can see that vegetation during sampling time are starting to regrow and covering the soil surface. Also, the same is with high severity burn treatment. Vegetation starts regrowth, and also it will for sure have effects on future sampling on rate of erosion and runoff. Here represent variability in treatments. Just one sampling date, 247 days after burn. We can see difference in the control and both burn treatments. So for statistical analysis, there we took the treatments and sampling date and calculate with two-way ANOVA significant differences between treatments and sampling date. I will now start presenting the results. Here the result of total nitrogen content. The content of total ash was higher in mode severity treatment but wasn't significant. In the soil, total nitrogen was significantly highest 5 days after burn. This was attributed to the fact that topsoil total nitrogen decreased in burned soil due to volatilization. Topsoil total nitrogen response in post-burn period varies among burn severity and due to possible different extent of ash incorporation into the soil. Maximum 30 minutes rainfall intensity was noted on the last day, when also the highest amount of rainfall was noted. And 155 days after burn can be singled out with a high amount and rainfall intensity. The highest runoff was noted at the last sampling date, and that can be attributed to the highest intensity and rainfall amount. The highest volume was also collected in the first sampling date and on the 155 days after burn. Both burn treatment showed several orders of magnitude runoff than the unburdened treatment. The variability of runoff on mode severity and high severity treatment is very light due to difference in small-scale variability in ash thickness. Ash might alter soil hydrological properties, increasing water retention and reduce the sediment loss. However, ash can also clog soil pores and increase surface erosion. Here represented the sediment yield, concentration, and total nitrogen loss. For the sediment yield, the highest was noted at 155 days after burn, where high intensity and amount of rainfall was observed. Sediment concentration was variable between measurement dates. However, they are very notably high in mode severity. In mode severity treatment, high sediment concentration was observed on first dates than in later dates of post-burn. Total nitrogen had similar result as the sediment yield. The highest total nitrogen was observed at 155 days after burn, followed by 25 and 52 days after burn. The highest peak of total nitrogen loss were a consequence of extreme rainfall events. After 4 months, peak loss are restricted to extreme rainfall events which can mobilize ash and soil. The highest amount and rainfall intensity, which was observed at 247 days after burn, did not significantly influence the overall flood and erosion rate. This was very light due to the sediment exhaustion as a consequence of the previous rainfall events. Our result agrees with previous studies that show a decreasing erosion rate in the later post-burn period. So here represent the nitrogen loss in post-pile burn period. On the left side, we can see data of ammonium. Two distinct ammonium concentration in unburned treatment and 180 and 247 days after burn can be explained due to rainfall patterns and related soil saturation. In the unburned treatment, the organic matter included a diverse composition of flora population, so it was assumed that this contributed to higher soil saturation and related increased ammonium concentration. Regarding the burn treatment, the minor ammonium concentration in most severity treatment was observed at 208 days after burn and in high severity and 65 days after burn, although not significantly different. However, nitrate is not produced directly by heating, but is formed during subsequent nitrification of ammonium as a result of burning. And that can be seen from the data in later sampling date. These results indicate that high-severity treatment had a severe effect on nitrate concentration in runoff, as the significantly highest value was observed in high-severity treatment. A more significant nitrate availability and movement are frequent when the nitrogen population recover. The ammonium and nitrogen loss follow the patterns of nitrogen concentration in runoff, as the loss is mainly influenced by and from concentration behavior. However, difference in nitrogen loss between treatments were more apparent than the difference in nitrogen concentration. This phenomenon occurs due to the post-burn transformation of ammonium to nitrate by nitrifying bacteria, increasing the transport of inorganic nitrogen. The ammonium is in the nitrogen soluble form and it's absorbed on the negatively charged soil exchange site and thus is less mobile than anions. Nitrate cannot bind to a soil absorbing complex and therefore is more vulnerable to leaching. In this research, maximum rainfall intensity was noted at 247 days after burn, but did not influence sediment yield, total nitrate at 155 days after burn. This could be attributed to the sediment and nutrient exhaustion and plant consumption. The second highest rainfall event with high intensity was observed when 155 days after burn, an increase in sediment yield and consequently nitrogen loss. In our work, sediment yield has more effect on nitrogen loss rather than sediment concentration. The sediment concentration was more influenced by first runoff events and 45 and 52 days after burn and did not have the same patterns as sediment yield as was found in previous research. We also applied the principal component analysis based on collateration matrix to identify relation among all variables. So factor 1 of principal component analysis grouped most of the erosion variables like sediment yield, sediment concentration, runoff, and total nitrogen loss. The erosion was higher in one-mode severity burn treatment comparing to unburned and high-severity burn treatment. The sediment yield and concentration, runoff, and total nitrogen loss are the best indicator to assess the impact of pile burn effects rather than ammonium concentration and loss and nitrogen concentration and loss. The erosion parameters are well documented in other studies as main features for identification of soil degradation in the post-burn period. Factor 2 grouped the precipitation parameters, amount and intensity, and also the ammonium concentration and loss. This can be attributed to the lack of significant difference in burn treatment, with the highest in control treatment for the ammonium variables. The highest ammonium values were observed at 247 days after burn in control treatment, when the highest rainfall, amount, and intensity were identified. The ammonium loss and concentration patterns differ considerably from those of nitrate, which were identified in factor 3. The nitrate concentration has had positive values. For nitrate value, it was observed different concentration and loss in both burn treatment, and it was not recognized as the main factor for the validation of pile burn effects. Pile burn leaves only localized soil impacts and nutrient effects. However, the effects are substantial. The accumulation of organic feedstock material in Mediterranean rural areas has become an environmental problem. There has been a need to manage unwanted harvest to avoid large fires and minimize their impact at all levels. Pile burn is recognized as an economical treatment for disposing of harvested residues, but the critical question in terms of sustainability of their practice is to what extent will alter soil function and cause soil degradation. Should soil before burning be protected somehow, or do benefits of pile burning overweigh the possible impact of soil? A fundamental guideline in discussing the effect of pile burning is the knowledge that soil is not renewable in our lifetime, which comes in the form in the Mediterranean endangered area. The post-burn nitrogen dynamic and nitrogen loss are useful indicators to rank pile burn effect in terms of consequences of soil fertility and soil degradation. Relatively small and localized burning area give preference to this practice. Pile burning can be used as a conservative approach that protects natural resources, which should be priority in land management, but do not neglect their impact on the soil. Different experimental design focuses more closely controlling fuel characteristics like amount, type, and moisture. Also, the season of burning, weather variables, and possible slope gradient are necessary to more clearly understand the period in which these practices are best to conduct. The conclusions of this research are next. The short-term effects showed a substantial impact on nitrogen loss in both burn treatments. However, severe impact on nitrogen loss was noted in most severe treatment. These work outcomes show that rainfall amount and intensity in the first month of post-burn had a minor effects on nitrogen loss compared to more severe rainfall patterns in later months. Pile burn has significant effects in a short-term study on nitrogen loss by runoff and erosion process. Sediment yield can be used as an important indicator for the determination of soil degradation in the post-burn period. The future work, with included analysis of physical and chemical soil and water parameters, is obligatory for deeper insight into the effects of pile burn practice on the environment. So thank you all for your attention. If anyone have some question or are dealing with similar research, feel free to contact me. Here are my email. I like to start new collaboration. This is the first paper published about pile burning in Croatia. And of course, more yet to come with different analysis and aspects. And also, soon there will be published the papers about wildfires in Croatia and mitigation of wildfires in Croatia. I hope you like it, and that is all for me. Bye.